So in this video, we will be going over partial decomposition. So that basically means when we have a fraction, we can decompose it into two separate fractions, which will be more easier to integrate or do any other functions on it. So it's a key method to be able to do other things. So here, the first thing that we want to look for is the highest power in the denominator. So the highest power of x here is 2. So what 2 means is that we have two unknowns, which are going to be a and b. And the next step is to factor the denominator. So here we can just find two numbers which multiply up to 10 and add up to -7. So it's going to be -2, -5, and we can rewrite this. So let me just do that. It's going to be 7x minus 23 over x minus 2 and x minus 5. And now we can write a as 1 over one of the factors, so one of the brackets, so x minus 2 plus b over x minus 5. And now we need to solve for a and b. So how do we do that? Do you guys have any ideas? So what we can do here is we can multiply the entire thing, or you can say we can multiply the right side and the left side by the denominator over here, so x minus 2 and x minus 5. So what I mean by that is, let's say x minus 2, and actually let me move it to the right so I can write that, explain. Yes, so what we need to do here is we need to get rid of the denominator. So what we can do here is we can multiply the left hand side by the denominator. So here I'm going to write x minus 2 and x minus 5, and this entire thing is going to cancel out and we're going to be left with this. And on the right hand side we'll do the same. So let's put the brackets around here. So this entire thing multiplied by x minus 2 and x minus 5, and here we, as the multiplication rules, so the first brackets a over x minus 2 multiplied by x minus 2 into x minus 5, so this part is going to cancel out and we will be left with a multiplied by x minus 5, and for the other part b, the x minus 5 will cancel out and b will be multiplied by this part over here. So what equation we will be left with is 7x minus 23 is equal to a, and a is multiplied by x minus 5, and now b plus b into x minus 2. And the other method that you can use is the cover up method, so that I can explain right now also. So let's say when we are writing for a, the brackets, we can cover up in the original equation, which is this part, original denominator, whatever the denominator for a is. So it's x minus 2, so if we cover up this, we'll be left with x minus 5. So that is the other cover up method, excuse me. And for b, we know that the denominator is x minus 5, so we can cover up x minus 5, cancel out this, and we're left with x minus 2. And now it's pretty simple forward. We can solve for a and b, and we can substitute x as 2 and 5. I can just do that quickly right now. So let's substitute 5. We'll get 35 minus 23 is equal to 0, so this entire thing is going to be 0. b into 5 minus 2 is 3, and solve for b, we'll get b as, I'm not going to go in details here, so just solve for b here. We'll get, so it's going to be 12 is equal to 3b, and b is equal to 4. Now do the other same thing for a. We're going to substitute x as 2 here, so it's going to be 7 times 2, 14, minus 23 is equal to a into, we substitute 2, so 2 minus 5 is negative 3, and here it is going to give you 9 is equal to negative 3a, and a therefore is going to be negative 3. Or wait, I made a small silly mistake here, so 14 minus 23 is going to be negative 9, and a is going to be 3. So yeah, so now we can substitute back into the original equation a by 3 and b by 4, and this is the partial decomposition. So let's do a similar example but a higher power of x. So here we have x cube, meaning that we have 3 unknowns. So it's going to be a plus b plus c, as the power of x here is 3, so that is determined, and next step is to factor the denominator. So you can do that on the calculator. So you're gonna get x as x minus 1, oops, and x plus 1, x plus 3. Here are the 3 factors. Let's write each of the factors below a and b and c. So this is it. And now finally we will multiply the entire thing by the denominator to get rid of here. So we will get x squared plus 4x plus 1, that's going to stay the same, is equal to, let's use the cover up method again. So for a, let's write a, and now let's cover up the denominator of a, which is x minus 1 in here. So we will be left with x plus 1 and x plus 3, so that is there. And do the same for the other values. So for b, let's cover up x plus 1, so we'll be left with x minus 1 and x plus 3, and then for c it will be x minus 1 and x plus 1. I need more space. And now we can start by substituting the factors of x. So let's say x is equal to negative 1, x is equal to negative 3, and x is equal to 1. So for x is equal to 1, when we substitute x is 1, we will get 6 is equal to a into, the other two are going to be 0 because this is going to make the entire thing 0 here, and this is also going to make the entire thing 0 here. So we will be only left with the a part. So it's going to be a into 2 and 4, and a is therefore, just gonna directly solve for it. It's going to be 6 over 8, so 3 over 4. Let's substitute a as negative 1 now. So we will get negative, so these two are going to be 0, this one and this one. So we'll only be left with the b part here this time. So it's going to be negative 2 is equal to b into negative 2, 2, and b is equal to half. And now finally for c, we are gonna substitute negative 3. So we will get c as, I'm just going to directly solve it this time, so negative 1 over 4. So until now we have done examples with real, distinct roots. So what if we have repeated roots or imaginary roots? So that's an entirely new thing, so we will be covering that in this video also. So let's start with that now. So let's start with another example. So here we have 6x plus 7 over x plus 2 squared. So what is the highest power of x in the denominator? When we expand this, it's going to become x squared. So we have two unknowns because the highest power will be 2. So a plus b, and how many roots do we have for this? So the only root we have here for x is going to be -2. Even after expanding, you will realize that you only have one root, which is going to be -2. And another way that they could have give you the denominator is the expanded version of this, where you had to factor it like this. So that's another thing to keep in your mind. So here we know that we have repeated, let me just write it down, repeated real roots. And how do we know that? The number over here, which is the 2, the power, is called the multiplicity. And multiplicity, so this tells us how many times the root is repeated here. So here it is repeated 2 times. It might be 3. This means the root is repeated 3 times. The one root is repeated 3 times. So here we will get a over x plus 2 and b over x plus 2 squared, since there is only one repeated real root and the multiplicity is 2. Now let's say, just as an example to make it more clear, we have x plus 2 cube. So we would have, as you know, 3 unknowns, ABC, since the x power would be 3. So a plus b plus c, and the denominator would be x plus 2, b would be x plus 2 squared, and c would be x plus 2 cube. And this is called the repeated real roots. So that's it for this one. And now we normally just solve it as we were solving before. So now let's write the equation. So it's going to be 6x plus 7 is equal to, we're just multiplying by x plus 2 squared, both sides, as repeated before. So it's going to be a, and we can use the cover up method. So x plus 2, and we deduct 1 x plus 2 here, so it's going to be x plus 2 plus b, and now we cover up this part, the denominator of b, in the original fraction. We're going to be left with 1. And if this is not clear, the cover up method is not clear, you can always just multiply the entire thing by x plus 2 squared. So here 1x is going to cancel out, and this is going to be 1, and then for the other ones it's just going to cancel out the entire thing, so like this. So yeah, and now we substitute x as -2. And if this is still not clear for you, because this was not clear for me when I was first learning this, what I mean by multiplying is just x plus 2 squared here plus b over x plus 2 squared multiplied by x plus 2 squared, and this would entirely cancel out. And when we simplify this over here, there will still be x plus 2, 1x plus 2 left over, and that's how we get this here. So you can either use this method or the cover up method. The cover up is pretty quick, you just quickly do it with that. So yeah, so now let's substitute x as -2. So x is equal to -2. So we will get, I'm just gonna directly solve it this time, so b as -5, and for a here we can substitute x as 0, and we will get a to be, and since we already have b, we can solve for a here. So it's going to be 2a plus b, and here a is going to be 6 here, and there we go. So our next question is a bit more complex, and I would need your attention here. So we have the denominator as x squared plus 1 into x minus 1 squared. Now, can we factor x squared plus 1? Let's try negative 1, let's try 1, and this is unfactorable. So what I mean by that is it has imaginary roots, and this we cannot factor any at all. And the factor for here, the other x minus 1, is just going to be 1, and we know from the last example that this is a repeated real root, so and the multiplicity here is 2, so this will be repeated 2 times. And the highest power of the denominator here is going to be 4, since x squared multiplied by x squared over here, once we expand this by the square, is going to give you x to the power of 4. So we know that we have a, b, c, and d. Now let's start writing the fractions on the right hand side. So the first fraction is just going to be, I'm just going to write the numerator for now. So the first fraction is just going to be the imaginary root, since we cannot factor this anymore, x squared plus 1, plus the next one is going to be x minus 1, and the last one is going to be x minus 1 squared. From the last example, it's pretty simple. It's repeated from there. And now we realize that we have 4 unknowns, which are a, b, c, d, but we only have 3 fractions over here. So whenever we have a fraction with a denominator of actually, let me rephrase that. The numerator is always 1 power less than the denominator. So in the first one, where we have x squared, the numerator here is going to be ax plus b, which you might recognize from your line of equation, which is like y is equal to mx plus b, where m here is a and b is b, x is x. So this only occurs when you have an x power of 2 or more. So one thing again to remember, the numerator is always 1 power less than the denominator. Here we're just gonna have c, and here we're gonna have d. And now comes the next part, where we multiply the entire denominator, and we can again use the cover-up method or just multiply it normally. So let's do that now. So 2x plus 4 is equal to ax plus b, and we can cover up x squared plus 1 in the original fraction. So when we cancel this out, we are left with x minus 1 squared, and now we can move that. Now next part is c, which is going to be c into, now we need to cover up 1 of the x minus 1, so we're going to be left with x squared plus 1 into x minus 1. And for d, let me just move this entire thing so we have more space, plus d, I'm going to change it to actually capital. So okay, d is into, we need to cover up x minus 1 squared, so we're going to be left with x squared plus 1. And here is the equation which we need to solve now for a, b, c, and d. Now we can start by x is equal to 1, since it makes most of these things 0, like this one here and this one here. So we can directly solve for d here, which we will get the value of 2 is equal to 2d Oh, one thing I forgot is that this is minus 2x plus 4, so it's minus 2x plus 4 here. Okay, my bad. And here is going to be minus 2x is equal to 2d. Oh, I mean, yeah, 2 is equal to 2d, which is that d is equal to 1. Another value that we can substitute in x here is 0. So we just need to try with random numbers now, until we get all our unknowns. So here we are going to be left with 4 is equal to b minus c plus d, and d we will already have it, so d we can just cancel out and replace with 1, and here we are gonna get that 3 is equal to b minus c. Let's substitute 2 in x here, so we are gonna get minus 5 is equal to 2a plus b plus 5c. So this is just a method until you get all your numbers here, so it's pretty annoying, not gonna lie. Let's substitute x as -1 now. So of course, like, the easiest numbers are 0, 1, 2 and 0, -1. So next is going to be -1, and you will be left with where is it? So I'm not going to go in much details over here, since the main step is to understand this part, and I'm going to write the simplified version here. So 1 is equal to -a plus b minus c, and here we did get b minus c, which is equal to 3, so we can substitute here by 3 and get a. So we will get 1 is equal to -a plus 3, and a here is, oops, yeah, as I was saying, a is gonna be here 2, and we can solve for every other value here then, and b is gonna be 1, and c is gonna be -2, and d we already got it, so d is equal to 1. So let's substitute a, b and c. So here's gonna be 2x plus 1, c is -2, and d here is 1. So let's start with our last example here. So first step again is what is the highest power of x over here, and there is a square, by the way, I forgot about that. It's going to be x to the power of 4 multiplied by x. So we have 5 unknowns, which are going to be a, b, c. I'm just going to write 5 for now, and we only have one real root, which is going to be 0. X is equal to 0. Since x squared plus 1 here is not, there are no real roots for that, that's imaginary roots. Since x squared plus 1, you cannot solve for x. So let's write it in that term again. So first one's going to be over x plus, second one's going to be over x squared plus 1, and the last one, let me write it in a better format, x squared plus 1, and the last one is x squared plus 1 squared. And now we can write the coefficients as before. So first one is going to be a, and what do you think the second one is going to be from the last example? It's going to be bx plus c, since the power of x here is 2, And for the last one is going to be dx plus e. And you might be asking that there is a square next to the entire thing, but we only look for the power of x. And this is the multiplicity number. So we ignore this. So let me write this in a better e. And now you might be wondering that since we only have one real root, it's going to take forever to keep solving for the equations and get a, b, c, d. So there is another method which is, I wouldn't say it's faster, it's a more not time taking, it's faster if you have less roots. So let's use that this time. So we are going to multiply by the entire thing of the denominator again as was before. So 1 is equal to, let's use the cover up method. So it's going to be x squared plus 1 squared plus b x plus c into we cover up x squared plus 1 over here. So we're going to be left with x and x squared plus 1. And for the last one is going to be dx plus e into only x. And now for this other method, we simplify as much as possible. So let's do that. A into, this is going to be x to the power of 4 plus 2ab, so 2x squared plus b squared plus we can do this here, so it's going to be x cube plus x, and we can directly multiply here, so we will get, multiply this, now just cancel this out with bx plus c, so we are gonna get bx4 plus bx2 plus cx3 plus cx, and for the last part we are just gonna get dx2 plus ex, and we can remove the brackets over here and distribute the a, so it's gonna be x to the power of 4 plus 2x squared, 2ax squared, my bad, plus a. So we simplified it as much as possible. Let me write this better, ax squared. And now we factor out the coefficients with the power of x's. So we can factor a and b together since both of them have x to the power of 4 together. So we can write a1 is equal to a plus b x to the power of 4. Now next is x to the power of 3, and we only have a c for that. So c into, actually we don't need brackets, 3 plus, now for 2 we have 2a, a b, we don't have a c, we have a d. So this is going to be 2a plus b plus d into x to the power of 2. And finally for x, factoring x out, we only have c and e here, so c plus e x, and we don't forget that we have an a left. Now let me ask you a very simple question. Let's say we have x squared and we don't know the coefficient of x squared, plus x is equal to 3x squared plus x. What do you think the coefficient is going to be? It's obviously going to be 3, right? Since we have an x squared over here. We are going to do the same exact thing with the coefficients of the left hand side and the right hand side. So for x to the power of 4, we don't have an x to the power of 4 over there on the left hand side. So a plus b is gonna be equal to 0. For x3 is gonna be the same, but we only have a c here, so c is equal to 0. For x2 we don't have a coefficient again, so 2a plus b plus d is equal to 0. For c plus e, it's again going to be 0 since we don't have an x on the left hand side. C plus e is equal to 0. And we already know that c is 0, so e is also going to be 0. And for a, we do have 1 here. So a is equal to 1. And here we can solve for e, so e is also equal to 0. So c and e are equal to 0. If a is 1, then what should b be here? b is equal to -1. And we are left with d now. So we know a is 1, so 2 minus 1 plus d is equal to 0. D is going to be equal to -1. So here I'm going to substitute back into this equation. So it's 1 over e minus x plus 0. And for d it is minus x plus e, which is going to be 0. So this is the final answer. And as always, I show a shortcut method for every question. So here we can substitute any value. Once you get the final answer, which is this part, you might be wondering, to reach each step. So what quickly you can do is you can substitute any value in x here. Let's say 1. Since we can't do 0, it's going to be undefined. So 1, and we will get something 2 squared times, so it's going to be 1 over 4, I think. And if we substitute 1 over here and we get 1 over 4 again, that means that our answer is correct, which it should be. So that is one shortcut method that I can think of. So yeah, thanks for watching, and I'll see you next time.